So like I said, you need to know these three. I'm not going to give you these formulas. Okay, so you need to keep that in mind. Okay, so this first problem says, write all possible expressions for x determined by the relationship between the exponential and logarithmic form of the equation 4 to the x equals 64. So on this one, if I have, oh, you're kidding. Okay, so if I have 4 to the x equals 64, how am I going to write that in logarithmic form? So 4 to the x equals 64. If I do the little circle of life, I can write this as log of base 4 of 64 equals x. So do we watch how that happened? Started at my base, go to the outside, finish at my exponent. Okay, if you ever forget which way you go or where do you start, you always want to start with your base. Start with your base, if this thing will load. Go to the outside and then finish at your exponent. So you spell out the word boy. Okay, another way I could write this is I could say log of 64 divided by log of 4. This is the change of base form. Change of base. And this pen is super lagging. So somebody in their calculator plug in log of 64 divided by log of 4. Log of 64 divided by log of 4. And tell me what you get. X equals 3. Good. Another way we could have actually written this out is we could say 4 to the x is equal to 4 to what power? The third power. Okay, so those are all the same thing, just written in 4 different ways. Questions, comments, concerns? All right, so looking at the next one, Morgan is 20 years old and wants to save $1 million for retirement in 50 years. Assume she invests in a savings account that earns at least 3 times the current rate of inflation, which is 2%. Determine how much Morgan must save to reach her retirement goal if the interest rates are compounded as listed below. All right, so which formula are we going to use? Compounded interest. Okay, so go ahead and write that formula down next to your little box. And I promise I'll scroll down in just a second. Yep, right next to the box. Second. Yeah, go ahead. Okay. Okay, so we're going to use that compound interest formula. Okay, so we've got P times 1 plus R divided by N raised to the NT. Okay, P is going to be my initial amount. R is going to be my rate. N is going to be the number of times it's compounded. And T is going to be the time. So how many times does something happen if I say it's semi-annually? How many times in a year? Twice a year, right? Okay, so when they say like that semi-annual sale, that's twice a year. How many times is monthly in a year? How many months do we have in a year? 12, good. If I say something is quarterly, how many times is it gonna happen? 4 times. Do we know how many weeks are in a year? 52. And how many days are in a year? 365. Good. Okay, so we're going to use these numbers to plug in. Okay. Now, Morgan wants to save $1 million at the end. Okay. So she's trying to figure out how much she actually has to invest. So that means that this is going to be 1 million equals, we're not sure what P is yet. We're going to say 1 plus, our rate is 3 times the current rate. So what's 3 times 2%? 6%. So we're going to say that is 0.06, because remember, we want to change percentage from a percent to a decimal. So it would be 0.06. And then we're going to plug in our how many times a year it happened, which is 2. And T is the only thing that we have it plugged in for. Now, what was our T? Time. So how long is she wanting this to take? 50 years, right? So we're going to write times 50. So how do we figure out what P is? How do we figure out what P is? By working out, yeah, okay. So we're going to plug this stuff into our calculator, and then we're going to take 1 million and divide it by this stuff, okay? One thing to be really sure of is when you type it into your calculator, you have to use those parentheses, okay? So I personally like using Desmos. So if I come in here and I say parentheses 1 plus parentheses 0.06 divided by 2, we're going to raise all of that to the 2 times 50. And remember, you're going to want to use your parentheses. And we're going to take 1 million and divide all of that. Okay, so we're going to put this over here. I hate Desmos when it does that. Yeah, it never pastes correctly though. Okay. So how much does she need to invest originally? She would need to start off by investing 52,032.84. I'm gonna write that down. So she would have to invest 52,032.84. Remember, we're gonna round to the nearest hundreds because we're dealing with money. Okay. I want you to take a second. I want you to try the others. Okay, so you try the others, and then we're going to talk about them in just a second. All right, so checking your work / kind of walking through it with y'all. Basically, the only things that's changing throughout here is your ends, right? So what would be the most beneficial for her? If she wants to make $1 million by the time she's 50, what would be the most beneficial one for her? Well, this is how much you would have to invest. Does that make sense? So like she would have to invest 52,000 and she would get $1 million by the time she's 50. Daily would be the best one. Okay. It's being compounded every single day. So she's making more money every single day. Does that make sense? Okay. Again, the beauty of actually using Desmos is just being able to go back in and changing that in value, right? Are there any questions about how I went about doing this? Okay, you got to use your parentheses, otherwise this ain't gonna work. All right, so it says neuroscientists have measured the growth of the brain connections in newborn babies. At birth, an infant has 50 trillion brain connections, which increases by a factor of 16 every 3 months. This growth can be represented by that equation. where m represents the number of months. Rewrite the function so that you can solve for m. Okay, so we're going to rewrite this function so we can solve for m. So right now we have b of m equals 50 times 16 raised to the m divided by 12. We want m by itself. The first thing that we're going to move is that 50. Okay, so we're going to divide by 50 on both sides. And so that's going to give us b of m divided by 50 equals 16 raised to the m divided by 12. Now, to get that m out of that exponent, we're going to take the log of this function. Okay, so we're going to start at our base, go to the outside, and then finish at our exponent. So we're going to say this is log of base 16 of b of m divided by 50 equals m divided by 12. Now, m isn't by itself yet. We want m by itself. So what we're going to do is we're going to multiply by 12 on both sides to get it by itself. So our final answer will be m equals 12 times log of base 16 of b of m divided by 50. All right, so let's look at this next problem. It says, in how many months will the number of brain connections double in an infant's brain? So remember, we start off with 50 trillion, okay? And obviously we don't have 50 trillion written right here, we just have 50. So what's double of 50? 100. Okay, so we're gonna say 100 equals 50 times 16 raised to the m divided by 12. Okay, so we're going to divide by 50 on both sides. And so that's going to give me 2 equals 16 raised to the m divided by 12. Now, in order to solve for m, we're going to take the log. So we're going to start at our base, go to the outside, finish at our exponent. So log of base 16 of 2 equals m divided by 12. We're going to multiply by 12 on both sides to get m by itself. And so then I'm going to go into Desmos and type this in. So watch carefully how I type it in. I'm going to say 12 times, go to my little functions button, scroll down to where it says log of base A. And then I'm going to type exactly what I saw over here. So I could say 16 of 2. And so what's that number going to be? 3. So it's going to take 3 months in order to double. Okay. One thing that I need you to make sure that you're paying attention to is make sure that you're reading. So for instance, up here, it's not just 50 that they started with. It's 50 trillion brain connections. Okay. Any questions on this? I'm gonna go ahead and scroll down. I know some of y'all are still writing. All right, so it says Sheila just graduated from college and started her first job 1 month ago. As a graduation gift, her parents gave her a 2020 red electric Prius, fully loaded, for $32,500. She intends to keep the car for the next 5 years. The equation which models this value of the car is right there. So what does 32,500, 0.79, and t represent in this scenario? Okay, so what do they represent? Price of the car. Good. What does t represent? Somebody said it. Over the next 5 years. Okay. And then 0.79, what does that represent? The rate of what? So when you buy a car, does it gain money or does it lose money? It loses its value, right? So this is the rate of lost value, car value, rate of losing value. We're going to call it that because I can't think of the word right now. Yeah, it's basically decay because it's less than that 1. Remember, growth is above 1. Decay is less than 1. Depreciation. Oh my goodness, that was so hard. Depreciation. All right, so we're going to rewrite this function to find what p of t is. So right now we have log of base 0.79 of p divided by 32,500 equals t. So now we're going to take this log and put it back into exponential. Okay, so we're going to do the exact same thing that we would do if we were going from exponential to log. We started our base, which is 0.79, go to our outside, and then finish over here. So what I mean by that is take your base, raise it to what you have out here, and then set it equal to p divided by 32,500. Now remember, my goal is to get p by itself. So what am I going to multiply by on both sides? 32,500, right? So our final answer is going to be p equals 32,500 times, I'm sorry, what? Oh, 0.79 raised to the t. Now let's say that Sheila actually kept it for 5 years. We're going to calculate the value of the car. Okay. So how would we go about doing that? If we calculate the value of the car, well, see, we've got this little function right here. What does p represent? Price. Okay. And it's price of the car after a certain number of years, right? Okay. So all I'm going to do is I'm going to take this equation I just found and plug in 5 for t. So this is going to be 32,500 times 0.79, and we're going to plug in 5 in for t. So I'm going to go into Desmos, and I'm going to type 32,500 times 0.79. We're going to raise that to the 5th power, and that's going to be 10,000.43. So just to make this clear, you went out and you bought this car for $32,500. After just 5 years, it dropped down in price to $10,000. So you know all these people who like go out and buy like these really expensive cars, in 5 years, it's not worth that much. So if you try to like resell it, you're not gonna get much. Just saying. There you go. Investment 101. Okay. Write a function q for which the output increases by 35% every time the input increases by 1. Write a function q for which the output increases by 35% every time, and the input increases by 1. Is that on the next one? Yep. All right, so go ahead and take a moment, think that one over. All right, so on this one, our output's increasing by 35% every single time. Okay, so when we do that, we're gonna say Q, if this will load. Just kidding. All right, so we're gonna say Q, and we're gonna multiply it by 1 plus 0.35. Okay, and then the input, we also call that our X values, is going to increase by 1 every time. Q is like our Y values, but they gave us this little title of Q for our Y values. And remember how I said it increases by 1 every single time? You remember how you said Q equals at the beginning? So sorry. So Q equals 1.35 every time our X value increases by 1. Does that make sense? Sorry, I wrote it like this. Okay, so we got 1 plus 0.35 raised to the Q, X plus 1, and we're going to call that Q. That was real messy. So thinking about this next one, it says R, for which the output decreases by 35% every time, and the input increases by 1. So we've got 1 minus 0.35, and we're going to increase by 1 each time, right? And we're going to call this R. Okay, so what's 1 minus 0.35?
0.65.
There we go, 0.65. And we're going to raise that to the X plus 1. So go ahead and take a look at number 6 and tell me what those numbers are going to actually mean for this equation or this problem. We're almost done. The pollen count is the highest over a period of approximately 8 weeks. The pollen count can be represented by this function where W stands for weeks. What do the elements 44, 12, and W divided by 4 of the function represent? So what does 44 represent? You're saying the highest pollen count? The initial pollen count, because that's what we're starting with, right? And we're saying that during these weeks, that's when it's the highest, right? Okay, so what does this 12 represent? Not months. What is this? At 12. 12 raised to the W divided by 44 is the initial pollen count. 12 is the rate. Okay. And then what's W divided by 4? Weeks. Okay. So why is it divided by 4? There's 4 weeks in a month. So this is representing the number of weeks in a month. Really, this actually is representing months. Sorry. This is actually representing the month. Okay. Oh. So if I say, oh, it happened over 6 weeks. Well, 6 divided by 4 is what? So if I said, okay, this happened over 6 weeks, well, what's 6 divided by 4? 1.5, right? So that's 1.5 months. Man, y'all making me question everything. All right. At what interval does the pollen count become 12 times higher? Explain how you know. Okay, so this is going to take a little bit more time than 5 minutes. So I'm going to get this on the next video that I do with y'all. Okay. What I want you to make sure that you are working on, if you have this class during 7th period, you need to make sure that you're working on this, because I've done majority of it for you. Remember, this entire review guide is due on Wednesday because you have a test on Wednesday. Okay. I'm gonna hit clear.